done the preparations of aliphatic aldehydes, aromatic aldehydes, aliphatic ketones, and aromatic ketones. Okay. So today we'll start or we'll discuss the physical properties of aldehydes and ketones. Okay. Physical properties, I'm just telling you, you can look at your book. So, okay. Problem is that regarding study, I'm very systematic, so I cannot discuss like that. First one is the physical state. Okay. Physical state. In your textbook, they have written everything together. Better to read always separately, then you will be able to remember. Physical state. Formaldehyde is gaseous in nature. It is existing in gas. And formaldehyde is commercially sold as an aqueous solution. The 40% aqueous, 40% by mass of aqueous solution of formaldehyde is sold commercially under the name called formalin. Okay. All of you have seen formalin. Have you seen formalin? Huh? Formalin you have not seen?
In biology lab where they preserve fishes.
Yes, you have seen in biology lab because it is found to be very good preservative. Specimens are being preserved, but thing is that, see, those who study science, a portion of it also people misuse them. So this formaldehyde now is being profusely used in the preservation of different food items. It's extremely toxic for our body. Okay, I think you have seen in Shillong also last 2 years back, the government has stopped selling of fishes because the fishes are being injected with formalin. They come from very far away places like Andhra Pradesh, UP, and Bengal. So they are being injected with formalin. Okay, so in that case, this is being used. Not only that, formalin is being profusely used these days for the preservation of the even fruits also, like apples, mangoes, everything which comes from outside. They are being initially dipped in formalin so that there is no decomposition from outside is noticed. Now, acetaldehyde is a highly volatile compound. Highly volatile compound. So acetaldehyde is also being sold as an aqueous solution. Rest of the aldehydes, most of the aldehydes up to C12 aliphatic aldehydes are found to be colorless liquid. But if aldehydes has a very strong and objectionable smell, which you cannot able to hear it, but as you go higher and higher, then their bad smell turns into a sweet smell, and especially the aromatic aldehydes, benzaldehyde has a very bad smell, but substituted higher aromatic aldehydes are having an aromatic flavor or fragrance, and they are being used as in the food also. I'm just one example I'm giving you. These are almost in all houses we use it. We have seen also this one, and we have used in making different types of confectionery items. This is a food flavoring agent. Okay. This chemical name is vanillin, and commercially it is being sold in the name of vanilla because this is being extracted or separated from the fruit of vanilla plant. We call it vanilla pods. All aromatic compounds have very nice smell, and the all aromatic ketones and the higher aromatic ketones are being profusely used in making different types of perfumes, and also is being used as a flavoring agent in food. Okay, so physical state got. Now let us come for this boiling point. See, aldehydes and ketones, they are polar compounds, no doubt. They are polar compounds. But their polarity is not as high as alcohols or carboxylic acids. So we can say in boiling point that the boiling point of aldehydes and ketones are higher than the boiling points of corresponding corresponding hydrocarbons. Hydrocarbons are non-polar compounds, so they have only very weak dispersion force or London force. But ketones are carbonyl compounds like aldehydes and ketones are polar compounds. So obviously they are held by dipole-dipole interactions. Held by dipole-dipole interactions. See, due to the difference of electronegativity, what will happen? The oxygen is going to put electron towards itself, and by that way the carbon will become electron deficient. So this is the dipolar nature of the carbonyl compounds. So whether you have taken aldehyde or ketone, you will find they will have dipole-dipole interactions. So because of that, you will find that their boiling point will be dipole. So the boiling point of aldehydes and ketones is higher than that of corresponding hydrocarbons. But their boiling point is far less than that of corresponding alcohols. Why? Because in alcohols, along with the dipole-dipole interactions, they also have strong intermolecular hydrogen bonding. Clear? So what we can say that boiling point of aldehydes and ketones are higher than corresponding hydrocarbons. But boiling point of aldehydes and ketones are lower than corresponding alcohols and carboxylic acids. Why? Because both alcohol and carboxylic acid are being connected with each other or associated with each other through intermolecular hydrogen bonding. So here we have compared with the hydrocarbons, here we compared with the alcohols. Now if you compare the boiling point of aldehydes and ketones, within aldehydes and ketones, which one will have higher boiling point? Okay, now see here. This is aldehyde. See, I have taken here CH3. Okay. I will take here isomer. Yeah. CH2. CH. We know aldehydes and ketones. What they show? They are the functional isomer. Same number of things. Look here. If you compare the boiling point of between aldehydes and ketones, so for isomeric aldehydes and ketones, we find the boiling point of ketones are more than that of aldehydes. See, same number of carbon atoms. Why it is like this? Look. These two methyl groups are electron donating in nature. So they supply electron to this electron deficient carbon. So what happens? That makes it more polar. Because constantly electron is being supplied. So the electron from the pi bond get repulsion and move towards the oxygen. All right. But in case of aldehyde, what you have? You have only one alkyl group. So in that case, the electron repulsion is less. That is, aldehydes are less polar than ketones. So please remember, between isomeric aldehydes and ketones. Ketones have higher boiling point because these are more polar due to the presence of two alkyl groups on carbonyl carbon. Right, this one. So this is the summary for boiling point. Right, right in 2-3 minutes. Then I'll go to the solubility. Can you hear me? Hello.
Yes, sir.
Yes, sir.
Okay. So have you finished?
No, sir, almost done.
Some handwritings are not that good. Okay. So here, last one I'm writing. Between isomeric aldehydes and ketone, ketones have higher boiling point because these are more polar due to the presence of two alkyl groups on carbonyl carbon.
What's the last word on the second point?
Second point,
Last word.
boiling point of aldehydes and ketones are lower than corresponding alcohols and carboxylic acids.
Okay, sir. Thank you.
Okay, no.
Yes, sir.
Here I should have written one more, right? Here within bracket you write. Put a bracket and write. Due to intermolecular due to intermolecular hydrogen bonding present in them. Due to intermolecular hydrogen bonding present in them. Today, I believe the students from the BSF also have joined.
Yes, sir.
Achha, how many do you know? Huh? Who are there? Ayushman, are you there? Huh? Ayushman, not there. Then who are those? Daniel?
Present, sir.
Hello?
I'm here,
Achha.
sir.
Then Mr. Slong? Huh? Then what about Yogma? Hello? Yogma is there? I do not know. When I call you, then why did you respond immediately? I think something serious has to be done with the BSF students. I do not know. Now the exam is also over. Huh? If they are not that serious, then I have to do something. Okay, finish.
Yes, sir.
Yes, sir.
All right, now we will go for solubility. Solubility. See, lower member means what? The molecules which contain less number of carbon atoms. Lower member aldehydes and ketones are soluble in water. Lower member aldehydes and ketones are soluble in water because they are taken from intermolecular hydrogen bonding with water molecules. Right? Lower member aldehydes, aliphatic. Lower member aliphatic aldehydes and ketones. Lower members of aldehyde and ketones are soluble in water yes they are associated with water molecules through intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Written?
Yes, sir.
Written no? Hello?
Yes, sir.
Yes, sir.
Yes, then right.
Yes, sir.
With increasing length of alkyl chain, with increasing length of alkyl chain, their solubility decreases. And finally becomes insoluble. Finally become insoluble.
Sir, can you please repeat?
With increasing length of alkyl chain, their solubility in water decreases. solubility of water decreases and finally becomes insoluble. Right. It is because the alkyl groups are, don't write alkyl. It is because the hydrocarbon are hydrophobic in nature. And with increasing molecular masses, their hydrophobic behavior, predominates. Over the polarity of carbonyl group. Over the polarity of carbonyl group. Today I forgot to put on the Bluetooth. I'll just do it now. So please bear with me for some time. Right? Let me bring. Bluetooth on ही होना देखिए. Okay. I could not put it on. All right. Now we'll go to chemical properties. Before going for chemical properties, let me draw the structure of the molecule again. Not molecule, carbonyl group. See here. In carbonyl group, both the carbon and oxygen are sp2 hybridized. This is sp2, this is sp2. Okay? Anywhere double bond is there, both the atoms are generally sp2. So sp2, you know, it has a unhybridized p orbital which overlaps to form double bond. And these are the lone pairs of oxygen. They are also under sp2 orbital. Okay. Here you have one electron and here you have one. Okay. So this is sp2. This is also sp2. So they overlap. So when they overlap, generally we show it like this, na? No, but the orbitals are like this. They overlap like this. So it will be, see, after overlapping, it looks like this, almost looks like cashew nut. This is the one. Okay, this is the one. So now the bond pair is here now. Pi orbital is here. But now we know that oxygen is more electronegative. So the electron migrates towards the oxygen. Now this orbital does not look uniform. In this place you have more electron, in this place you have less electron. Then how it will look like? It will look like this. My drawing is very bad, huh? Some of you, your drawing is so nice. Okay. See here, you have larger electron density near oxygen. So generally, how will you write now with the bond line structure? With bond line structure, we draw it like del plus and del minus. Please draw this one. Huh? Orbital structure of carbonyl group. Orbital structure of carbonyl group. After finishing, you please tell me.
Finish, sir.
Okay, now see. Now we will try to see what are the different types of chemical reactions can be shown by aldehydes and ketones. All right. So let me wrap this one. Types of, write down types of chemical reactions. One. See, any compound which is having double bond, it may be between carbon-carbon or it may be between carbon and any other atom. It is an unsaturated compound. Okay. So they will always undergo addition reaction. Okay. So I'll write here now. Nucleophilic. I'll tell you why it is nucleophilic. Nucleophilic addition reaction. Second one is everything I'll explain. Addition elimination reaction. Third one, we'll go for reduction. Reduction means what there? Reduction means we are adding hydrogen, but we will not discuss here. Reduction. Fourth one is oxidation. All right. Fourth one is oxidation. Fifth one is properties due to alpha hydrogen on aliphatic not aliphatic, alkyl chain of alkyl chain in aliphatic aldehydes and ketones. On aliphatic aldehydes and ketones. Sixth one is the electrophilic substitution on aromatic ring of aromatic aldehydes and ketones. See, I have sent you the summary. Yeah, everything is written there. If some of the words you are not able to hear properly, or some of the words you are not able to understand, everything is written in the summary. So these are the different types of properties shown by aldehydes and ketones. Write down, then we'll discuss one by one. Finish.
Yes, sir.
Hello?
Yes, sir.
Okay. Now let us go for the first one. This one you try to understand. Now you need not write. Everything I told you now is written there. You need not write. Nucleophilic addition reaction. I told you that why it undergoes nucleophilic addition reaction. See, addition reaction can be of two types. It is who starts the reaction. See here. Suppose I have taken a substance like this. Why I have taken NuH? Because you know it very well. It will give you Nu minus and H plus. Now the question is that who initiates the reaction? If the reaction is being initiated by H plus, then we'll say it is electrophilic addition reaction. And if it is being initiated by this, then we are going to call it nucleophilic addition reaction. See here, take the example, it is ethene. All right. It is you have a double bond between two carbon atoms. They have the same electronegativity. In this case, you will find this molecule is non-polar. So how you are going to make it polar? That is, you have to disturb the electrons in between these two carbon-carbon double bond. So how generally we do? Normally in a civilized place, if you want something, you request them. They please give. Then there will be some kind-hearted person. He may feel pity on you and he will give you. That is, you are going to beg. So in case of this carbon-carbon double bond, see here, these are the electrophiles. Means what? These are Lewis acids. It can be H plus or any other Lewis acid like BF3, Cl3. So when they approach the carbon, any of the carbon, depending upon their stability, they will supply the electron. All right. So these stable addition reactions are being initiated by electron deficient species. Because of that, we call them as electrophilic addition reaction. But in case of carbonyl group, thing is not like this. Okay. In case of carbonyl group, see here, we have some structural problem. What is the structural problem you have? This molecule is non-polar. Why it is non-polar? Sorry, this molecule is polar. Why? Because after the formation of double bond, the carbonyl group, you have a bond between carbon and oxygen with a large difference of electronegativity. So oxygen already starts pulling electron, and you will come across a situation where it is like this. See here. So carbon atom is electron deficient. If the carbon atom is electron deficient, can it give electron to any other electron deficient species? No. In fact, it will seek electron from others. From whom? Those who are electron rich. And the electron rich species are called nucleophiles. All right. Due to that, you find that carbonyl group undergo nucleophilic addition reaction. All right. Nucleophilic addition reaction. Now, this is the theory. Looking at the molecule, this now you have will be enough knowledge is there. We can apply it to human being. See, if you find your opponent is stronger, obviously you will not go and challenge him. Okay? In that case, you are going to request him. And if you find the opponent is weaker, in that case, you can bully him. So this is weaker. And you are the reagent. All right? So please remember, as because this is called carbonyl carbon. The carbonyl carbon is electron deficient. Okay, and in that case, all the addition reaction will be initiated by nucleophiles. Now see, the structure which I have written, please dear remember, this is not resonance. This effect is called Mesomeric effect. And it is a permanent effect because as long as the carbonyl, as long as the double bond exists between carbon and oxygen, oxygen will constantly put electron from the double bond because it is the inherent property of the oxygen. You cannot stop it. So this effect is called Mesomeric effect. Then when we will call it resonance? Many of the books they write resonance. I also in sometime have written resonance because it is easy for you to understand. Mesomeric effect is that if this effect propagates in the other part of the same molecule, then we are going to call it resonance. Just like if you throw a stone in the pond, initially a ripple is being created. Okay, but this wave or ripple is not stagnant. It moves. So the ripple, initially the ripple that you have created, the wave which you have created by throwing a stone, that is Mesomeric effect. And when the waves moves towards the bank, it continues, that is called resonance. So please remember, this exists in the Mesomeric effect. Mesomeric effect is a permanent effect. Permanent effect. Now, let me tell you one more one.
So that, sir, so
Hello?
that means mesomeric effect causes resonance.
Yes, Mesomeric causes initiates resonance. You cannot say cause, because if there is no double bond, if another double bond is there, see here. Suppose you have taken an unsaturated aldehyde. Okay, suppose it's unsaturated aldehyde. So what will be the first one? First one will be this. See here. Now what will happen? Now this moves no to compensate. So from here to here is Mesomeric effect. When this moves, what do you get now? See here. Is it not effect from this carbon has migrated to this? From here to here is resonance. And from here to here is Mesomeric effect. So who has initiated the movement of electron? It is the Mesomeric effect. So this is Mesomeric effect. From here to here is resonance. But the thing is very, very confusing to many people or even to the student. Because if I don't tell you, then how will you know? Please remember, resonance is being created by the Mesomeric effect. But in case of benzene, we also have drawn the resonance structure, mind it, dear. But in case of benzene, we did not have any electron difference between the carbon-carbon bond. So, in that case, the electron, just for the stability, molecule itself pushes the electron. That is resonance. All right. In case of, you'll find if you read this, your big reference book, you'll find the Mesomeric effect, resonance, sometimes they write plus M effect, minus M effect. These are nothing but the plus R effect and minus R effect. Okay, forget. Now, how do you carry out this nucleophilic addition reaction? How do you carry out? Whenever we carry out a chemical reaction, to that we add side by side, we add different types of substances. Just like when you cook, only vegetable is not, if you boil it, there is something else. But while making curry, along with the vegetables, we put different types of spices. All right. So, whenever we carry out the nucleophilic addition reaction, always there is some medium is there. All right. So, in that case, nucleophilic addition reaction can be carried out in acidic medium or in the basic medium. Okay. So, we can classify nucleophilic addition reactions can be classified as 1. Acid assisted and second is base assisted. Okay, acid assisted or base assisted. So let us see the first one, acid assisted. So nucleophilic addition. Okay. See here. So I have gone for acid assisted. So in that case, what you will have here? I have taken nucleophile and I have taken here H plus. So let me write here electron rich. See. So see here oxygen is having 2 lone pairs. So it is a Lewis base. What you have now here? Electron deficient proton. So immediately there will be Lewis acid reactions. So what you are going to get? You will get here see here. You've got this oxygen has become trivalent. So what will happen to this trivalent oxygen? In that case, you will find the oxygen into full electron. So what you will get now? Look now. By adding H plus ion, you have made this carbon more electron deficient. Initially, it was like this now, del plus, and this is del minus. It's just like that. Suppose you are hungry. When a plate of food is brought near to you, you feel more hungry. So it is like this. Then after that, what is going to happen? Why did I draw it like this? Because in that case, now in this case, see here, this is the, you have shown the resonance structures. Now, what is going to happen? See, this is a nucleophile. Now, nucleophile immediately attacks the carbon, and you get here so this is the addition product. This one you please draw. This is the acid assisted. Today after the class, all of you send your presents. I want to see that how many did not attend. I shall talk to them permanently and try to solve the matter permanently.
Okay, sir.
It cannot be like this because I'm sending video. It doesn't mean that you should not attend the class. I'm sending the video only for your convenience. In that case, I will not send the video in future. Finish. Finish.
Yes, sir.
Okay. Now we'll go for
Yes, sir.
gases. Okay. Basis system. Okay. So I have taken here now again this carbonyl group. Oh. And now what do we have here? I have taken here. See, I have taken here. This is a neutral molecule. And here what I have taken? Base. Which is minus. It may be any other base. See what is going to happen now. In this case, this is, see here, this is a Lewis base, this is also a base. You know very well the two bases, they do not react. Okay, so it is not going to react with this. Okay, now see what is going to happen. This is a weak nucleophile, and this is a neutral nucleophile. We know it very well that when from a neutral molecule hydrogen is being removed, look, you get its conjugate base. You get its conjugate base. And as I told you, it is a weak nucleophile. So conjugate base of a weak substance is a strong base or a strong nucleophile. Strong base is a strong nucleophile. All right. So now what is going to happen? Now this nucleophile is very strong. So because of that, immediately attack the electron diffusion carbon of the carbonyl group. What you will get now? You will get Nu minus, sorry, Nu and O minus. All right. Any reaction that you have done in alkaline media, it has to be neutralized. So how do you neutralize an alkaline medium? Obviously by using an acid. So the O minus is, see, it will go there and you get the same thing. Please write. Written there.
Yes,
We're
sir.
almost done.
So let me again explain to you. When we carry out this, see, whenever we carry out nucleophilic addition reaction, it is always not necessary the nucleophile has to be very strong. Okay? So in that case, those weak nucleophiles we carry out in alkaline media. Or if the reaction becomes slow, then also we add base there. So by that way, what we create? We create the anion of the nucleophile. Anion of the weak nucleophile are stronger nucleophile because we know the theory of conjugate acid base. Immediately the nucleophile attacks there and you get this intermediate. Then after that, the reaction is being neutralized by acid, and see here we get the same thing. One more interesting thing is that, please remember, this carbonyl carbon is sp2, that is the molecule is plain. Yeah? In that case, this is sp3. All right. Now we are going to discuss. Excuse me. এই যে মেশিন অফ অফ করতে হতে লাগে। না না আমি না এটা কোন কথা বললাম তুমি নিজে তারাইয়া উদিকে চলতে পারে যখন কমি গেছে okay now we are going to discuss which one will be more reactive towards nucleophilic addition reaction, aldehydes or ketones. This is a very important one for your board exam, both CBSE and MBOS. You'll find after 2-3 years this question always comes. So this question is not being asked for, I think, to the last 2-3 years in the board, especially MBOS, because I'm not that much familiar with the CBSE question type. All right. So I'm telling you, it might come next year. Which is more reactive, aldehyde or ketone? In my note, I have written it. Try to understand, then you can write down from there. See. This is an aldehyde. And this is a ketone. Clear? I am now taking the example of aliphatic aldehydes. See here, this carbon is electron deficient. In both the cases, it is like this. Look, we know alkyl groups are electron donating. They have plus I effect. So here you have one, and here you have two. See, this carbonyl group is same for both of them. So this oxygen is going to attract electrons with same degree from this carbon and same carbon, this carbon. Now here you have two. Here you have only one alkyl group, and here you have two alkyl groups. So in this case, which carbon will be less electron deficient? This carbon will be less electron deficient. Okay. See, suppose you because at this age you have no source of income, so you are being constantly assisted financially by your parents. All right. So in our house, it may happen that one of the parent is working, and in other house both the parents are working. In that case, if one of the parent is working, he is the only source of the supply of money. In this case, both the persons are supplying money to you. So in that case, what you will find, this carbon will be less electron deficient, and this will be more electron deficient. And so in this case, aldehyde, you will find that aldehyde will be more prone towards nucleophilic addition than that of the ketones. So this is called electronic factor. Electronic factor. I will explain everything with simple language, and even after that one also, if you do not understand, tell me again, I'll explain. This is electronic factor. Second, the reaction has to go through some intermediates. See here, now I am not drawing anything here, R and R. Simple nucleophilic addition reactions I am doing now here. You know it very well, nucleophile. Clear, dear? So see, this is sp2 carbon. sp2 carbon means what? It's just like my hand. Okay? You think that this is the carbon, this is oxygen, this is the one alkyl group, and here you have another alkyl group for ketone, and aldehydes only hydrogens. Hydrogen is very small in size. Now see here. This is the nucleophile. This nucleophile can attack from front side. This nucleophile can attack from back side. Now, when it attacks, what do you get now? See, now this is sp2 and this is sp3. This is planar where you do not have any obstruction at all, and here it is tetrahedral. Okay, now see, if these two alkyl groups are big in size, then nucleophile immediately cannot attack, because this intermediate becomes unstable because of the obstruction or steric hindrance. Okay, what is this? This is ketone. And okay, so in case of ketone, due to the presence of two alkyl groups on the carbonyl carbon, the process of addition becomes slow because of steric hindrance. Or I can say, if I would have taken an aldehyde, if this instead of R2, if I have aldehyde, then in that case, the obstruction would have been less. So on these two factors, if we analyze, you will find that aliphatic aldehydes are more sensitive, or they are more reactive towards nucleophiles. Again, I'm explaining that aliphatic aldehydes are more reactive than ketones towards nucleophilic addition reaction due to two factors. One, you call it the electronic factor. What is the electronic factor? The carbonyl carbon is electron deficient. But in case of ketones, the carbonyl carbon is bonded to two electron donating alkyl groups, by which the electron deficiency is decreased. Second is called steric factor. Steric factor means it is a question of the space. Steric factor. What is the steric factor says? We will say the nucleophilic addition reaction or to aldehyde and ketone proceeds through a sp3 hybridized intermediate. Due to the presence of two alkyl groups in ketones, the reaction suffers from steric hindrance, by which the addition process becomes slow. Hence, we can say that aliphatic aldehydes are more reactive than aromatic ketones towards nucleophilic addition reaction. Okay, then this is being written in your book also, and I also have written there. Whichever one you find easier for you to write or understand, to read that one. Now, let me discuss. I'll take 5 more minutes, because 9 o'clock you will have class from school. Now we are going to compare reactivity towards aliphatic aldehydes and aromatic aldehydes. Aliphatic aldehydes. Okay, let me take here this. And aromatic aldehydes. Okay, so let me take this. Okay, so this is acetaldehyde, and this is benzaldehyde. Why the aldehydes and ketones undergo nucleophilic addition reaction? Simply because the carbon of the aldehyde and ketone are electron deficient due to Mesomeric effect. All right. So I'll write here del plus del minus. Here also right, del plus and del minus. There, let me take this one. So I'll write it. It's very, very, very easy. It's not that we are talking something of the MSc level or BSc level. See here. This is del plus and this is del minus. So what is going to show? Initially is what? Mesomeric effect. Now you will understand the difference between mesomeric effect and resonance. See here. I'll write here C minus, sorry, O minus and C plus. See, from here to here is mesomeric effect. But this effect will not stay only located to carbon-oxygen bond. Why? Because we have alternate double bonds. So the thing will now propagate. What is going to happen? This electron deficiency of carbon will immediately compensated by movement the electron from benzene ring. So what we will have now? Sorry, for some time we will not be able to see. This. Now this electron will go. It will come here. Then it will come here. Then it will come here. Okay. Now let me draw this resonance. Yes, mesomeric structure. What will have? Okay, now let us see. Don't write now. See here. In this case, out of the two structures, in one structure you have positive charge on carbon. So what is the contribution or presence there? 50%. 50% of the structure has positive charge on carbonate. In this case, how many structures I have drawn? 1, 2, 3, 4, 5, 6, 7. Out of these 7 structures here, on which structures you have positive charge on carbon? This and this. Okay? So, what is the contribution now? Out of 7, you have 2. So, out of 100 will be how much? 200 divided by 7. How much it comes? Okay, let me just make it simple. So, it is near about if it is 210, then it's 21%. Is it not? So in that case, did I do any mistake? Percentage it comes all right. 21%. So how much it comes? 2 out of 7. And yeah,
Actually, it will be 2 out of 7 by. Yes.
Oh, it will be 7. 7 by 200, na? You got 2 out of 7. Okay, anyway,
21% only.
Okay, 21%. So in that case, which molecule will be more electron deficient? Is it not this one? Huh? So please remember what we are going to explain now, because in mathematics we will not say like that. In our chemistry, what we will say? We'll say the electron deficiency of carbonyl carbon is being greatly compensated by the resonance effect. Hence, you will find that aliphatic aldehydes are more reactive than the aromatic aldehydes. Aliphatic aldehydes are more reactive than aromatic aldehydes. Now, if I write their reactivity, okay, what will be the reactivity now? Reactivity series is which is the most reactive? See, now formaldehyde. It does not have any electron donating group. So this carbon will be extremely electron deficient. Then comes this. Okay? Then this. Then comes this. Then comes this. So this is the reactivity series. This is the least one. Why? Because you have two phenyl ring. Both sides will show you resonance effect. And see, the sizes are larger. So you'll find most reactively formaldehyde, followed by any aliphatic aldehyde, then any aromatic aldehyde, then any aliphatic ketone, then aliphatic alkyl, this is called alkyl aryl ketone, then you have diaryl ketone. So this is the reactivity series. Okay, so from tomorrow we'll start doing the examples of the nucleophilic addition reaction. So again, I'm telling you, just I summarize you in 2-3 minutes. We find that aldehydes and ketones, both of them have carbonyl group, and due to the mesomeric effect, the carbon of the carbonyl group is electron deficient, and hence they show nucleophilic addition reactions. Nucleophilic addition reactions can be carried out in two different ways, either in acidic medium or in basic medium. Okay? So in case of acidic medium, the oxygen of the carbonyl group gets protonated, by which it generates a very strong electron deficient carbon atom, which is being immediately attacked by the nucleophile. And in case of basic medium, the bases generates stronger nucleophile anion from a neutral nucleophile, and that way the reaction proceeds and it has to be finally neutralized to get the product. And in both the cases, the product that you get is same. All right. Now we want to compare between the aliphatic aldehydes and aromatic aldehydes towards nucleophilic addition reaction. We find the aliphatic aldehydes are more reactive than aromatic ketones. Why? Ketones. Why? Because in case of ketone, you have two alkyl groups, electron donating alkyl groups on the carbonyl carbon, and that makes the carbonyl carbon less electron deficient because they are constantly supplying electron to the electron deficient carbon. In case of aldehyde, only one alkyl group is there, so its deficiency is more. This is called electronic factor. Then the steric factor. In steric factor, we find that nucleophilic addition reactions always go through a sp3 hybridized intermediate. So in case of ketone, due to the presence of two alkyl groups, it creates steric hindrance by which the process of nucleophilic addition becomes slow. In some cases, they do not even react with bigger nucleophile species. Now, when you compare between the aliphatic aldehydes and aromatic aldehydes, we find that aromatic aldehydes are slower towards the nucleophilic addition reaction. Why? Due to resonance effect, the electron deficiency of carbonyl carbon is greatly reduced. Hence, aliphatic aldehydes are more reactive. Now, if you make a series of, if we arrange them in order of reactivity, we find the most reactive aldehyde is the formaldehyde, because formaldehyde does not contain any electron donating group. So the carbon remains extremely electron deficient, followed by aliphatic aldehyde, then aromatic aldehyde, then aliphatic ketones, then alkyl ketones, then you have alkyl aryl ketones, and finally the diaryl ketones. Thank you. So please mark your presence, and those who did not come, I think something serious has to be done.
Thank you, sir.
Thank you,
Welcome.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Goodbye, sir.
Thank you, sir.